Hello, I'm Dennis K. McKay, and you're watching the video series I'll call SurveyorThink. This episode is about ideas about how surveying data can best be made available to anyone at any time over the internet. So imagine on your screen a globe such as Google Earth, and you have zoomed into your neighborhood and you turn on the parcel and cadastral layer. Now, you can query all the public information about the parcel you live in, such as its assessed value, residential zone code, school district, and on and on. And you can ask if the federal government has maintained their subsurface mineral rights under your property, or do they still maintain their rights to build ditches and canals? But enough imagination, you can't do this. You might be able to go into your county or city's website and get some of this information, but if you pan over to the next county, or it will be blank, and you would have to go into that county's website. So here's the thing. What if parcel data were just like we imagined? What if there were only one version of parcel display that was linked seamlessly across the country, and everybody concentrated on making this parcel data the best it can be? This would make it easy for users to find parcel data because there would only be one version of them that is just shared instead of multiple and redundant efforts at parcel creation and maintenance. Now, this idea is not mine. It's a concept that is over 40 years old, and an idea created by government, academic, and private industry leaders over a year who put their heads together and identified how much we're all wasting money creating a multitude of redundant parcel data sets. The resulting booklet is called The Need for a Multipurpose Cadastre, right here, and funded by the National Research Council, and presented to Congress in 1980. This idea of a multi-purpose cadastre predates IBM PCs and Apple Macintoshes and the World Wide Web as we know it. But Congress appreciated the idea so much that they soon funded a project to create this multi-purpose cadastre. It needed standardized data design, it needed software to collect the data into this design, it needed survey measurement data to be hand-entered from plats into this standardized design. Now, the function of the federal government that was chosen to design this system, this multi-purpose cadastre, was the Bureau of Land Management, cadastral surveys, which would also collect the survey data, delineating past and present federal government boundaries, including the public land survey system, with all the sections broken down to at least the 40-acre parcel level. This project is called the Geographic Coordinate Database, or GCDB, and it has basically collected the western states, as you see here, with each one of these dots represents a township or land grant. It is considered outside BLM's jurisdiction, however, to collect and track private land holdings. So while this system was designed to accommodate everybody, like cities and counties and state governments, to create a coast-to-coast parcel depiction, it would be those local agencies' job to actually add their survey measurements to the GCDB data, densifying and improving the parcel geometries, ultimately becoming the multi-purpose cadastre, which never happened. But while the BLM was developing survey measurement data standards, other functions in the mapping world decided to follow suit with the multi-purpose cadastre idea. The Federal Geographic Data Committee formed 7 framework themes that would comprise the national spatial data infrastructure. this data would be available for free at all times over the internet. An example of a national theme would be roadways, which would be overseen by the Federal Department of Transportation. The 7 themes would be topography, overseen by U.S. Geological Survey. The cadastral theme would be overseen by BLM Cadastral Surveys. So the cadastral theme of the National Spatial Data Infrastructure has evolved into being 2 standards. The standard in place for use by the public is referred to as the CadNSDI. It contains parcel names and their shapes, and it contains points at the parcel corners with attribute information that includes, importantly, the unreliability for each of the parcel corner coordinates. Relative information extracted from the BLM's GCDB has been imported into CadNSDI geodatabases that can be downloaded in files, but not accessed real-time yet. It has no data that is of use to surveyors beyond just being able to navigate to a relevant location. The second standard is called the production standard, and it was envisioned as the repository for surveying measurements, but the standards were never developed as part of the National Spatial Data Infrastructure, with one exception. A national standard for the sharing of GPS measurements of parcel corner monuments was developed with some of the cadastral subcommittee members and implemented by the state governments of Montana and Idaho. There's still no recognized national standard for historic plat measurements, nor of databases of instructions for how to subdivide unusual sections or prevent tri-station ties from showing up in parcel depictions, and managing curve geometries and many other operations that really bridge the difference between measured survey lines and parcel boundary lines. Once developed, though, these standards will allow the survey community to perform geometric data analysis and to finally create a sustainable and defensible multipurpose cadastre. The CadNSDI being the public-facing portion of it. A much larger and complex survey measurement geodatabase tables, which were once only conceptualized by the FGDC, could also be published openly, accessed through specialized software for use by surveyors. The takeaway message in this episode is that some standards exist and some data exists, but more standards need to be finalized in order for local agencies to densify the GCDB into being a sustainable and trustable coast-to-coast surveying and parcel data set that's useful to both surveyors and the general public. This data could be published openly. In future videos, I will describe and defend the data standards I designed and have proposed to finally complete the national standards for surveying data, which in conjunction with the public-facing CadNSDI will support a functioning multi-purpose cadastre. Thank you. My name is Dennis K. McKay, and the video series you're watching has the keyword SurveyorThink.